Good morning. Thanks everyone for joining the January 4th, 2018 VOLTHA TST call. And today we're going to have some discussion about architecture and framework to support OpenOMCI implementation for VOLTHA. And so we're planning to have two presentations today, one from Chip and one from Sean. And I believe we will start with Sean's presentation. I'll hand presenting rights over to him in a minute. And a reminder to all that the meeting is being recorded, and then we will post this later to the VOLTHA playlist. All right. And then because we do have just an hour reserved for this, we'll try and make sure we keep the discussion for each presentation limited to 30 minutes so that we can give enough time to both presentations. And if we don't need that much, that's fine. And then a reminder to everyone as well that we are planning to close Sprint 4 and finish up 1.2 by tomorrow, so we can have discussion on VOLTHA Discuss as needed for that also. Okay, and Sean, you should be presenter now. So let me know if you have any issue.
Okay.
There, I see your presentation.
Okay, so there's actually, I have a couple of presentations, but probably not time to go through a lot of detail on each one. There's a couple of areas I kind of want to talk about that are related. So one is traffic management in general, and basically, you know, how we're going to best support you know, downstream QoS and various service types. You know, so basically we have the XPON provisioning, the WT385 that kind of Nokia. Oh, and before I go on to that, so someone just notified me that really I shouldn't be showing anything about RAID assist on the slides, so I apologize for that. I haven't had a chance to clean this up. And if there is a template that you know is recommended to be used, if you could maybe send me a link or something like that, I can put the slides in that format. So basically the OpenOMCI I'd like to discuss is kind of related to kind of use cases, and the presentation is basically around basically service creation and different types of services. Again, and this relates to you know, traffic management in that, you know, we're using XPON interface to create different types of services by, you know, creating TCONs and gem ports associated with VENet interfaces, as described in the 385 document. So I do have a proposal for how we can add downstream QoS, but basically, you know, I'm just currently, if we look at the way that we create services right now, we have a combination of OpenFlow plus 385 provisioning. So with the OpenFlow gives us the, you know, match action rules, 385. Sorry, just want to say something? No. So and 385 gives us the kind of the structure of the TCONs and gems and interface mappings, and basically that information is basically combined together, right? So in VOLTHA to create provisioning for the OLT and provisioning for the ONU via the OMCI, right? So basically we need to take the, you know, the OpenFlow information and the 385 information, combine that together and essentially generate OMCI messages. So if we look at the models for creating these services, like I said, we use the 385, which we can potentially augment to support downstream traffic management, and OpenFlow to give us information about PB mapping, and the tag action operations we need to perform on the the ingress of the ONU UNI interface. And there are several types of services that we're being asked to support. AT&T has its OpenOMCI definition of services where, for instance, there's a data service. It's a one-to-one type service. In this case, it terminates on a UNI. And it's basically asked to create 4 classes of service. It's a multi-class of service type service. There's 4 gems associated with it. Each gem is a traffic class, is associated with a priority queue on the TCON. There's some p-bits that get mapped into each gem port, and there's a scheduling policy that in theory we can create using the 385 modeling. And so this is one type of service. Another type of service that's in the OpenOMCI document that AT&T has is the Voip service. In this case, it describes a 2 class of service. It's end-to-one service, typically POTS UNI, and 2 gem ports with p-bit mapping into the gem ports themselves. Another example of a type of service is from DT, where there is, again, it's a one-to-one type service, terminating on a UNI, and there's 8 classes of service. Each p-bit has its own gem port. Strict priority scheduling in that case. Another use case is strict, a typical TR-126 4+1 service model, and basically in this case, we have 4 TCONs for services. Each TCON is associated with a single gem per UNI, and for each class of service, like class of service 1 may be the best effort service. So basically, we map, say, p-bit 0 or whatever number of p-bits we want into the best effort service. We map that to class of service 1. Same class of service 2. It may be an AF1 service. Class of service 3 may be AF4, and then maybe an EF service for class of service 4. So once we take the inputs for these different types of services, right? So we have the OpenFlow information, we have the 385 information, and we need to convert that into a set of OMCI messages for the ONU plus the OLT provisioning itself. So from a high level, I mean, basically, if we look at, say, creating the first of those use cases, the AT&T data service, where there's a single TCON for gem ports. So basically the messages, the provision comes into the system, through the management interface for the 385 and through the OpenFlow interface for the OpenFlow tag action rules. And so at some point, somewhere, this is combined for provisioning to go to in the case of the edge code OLT, and there needs to be some indication to the ONU adapter that getting some feedback here. So it's better. So at some point, someone needs to create a service. So in this case, we wanted to create this one-for-one multi-class of service for UNI type service. So at some point, once that happens, we take the provisioning information and we need to do some OMCI provisioning. So based on all this particular service, we need to generate this whole set of OMCI messages, right? So currently, the ONU adapter is the one that takes the provisioning information and essentially generates a fixed set of OMCI messages that goes down to the provision of the ONU for a given service. So when we talk about an OpenOMCI framework, we're going to have to come up with an architecture that allows us to request different types of services based on the provisioning, TCON gem mapping, the P-bit mappings, the bandwidth profiles. All that information needs to be collected, and then there needs to be some, say, ONU adapter or OpenOMCI microservice or module that can be that can generate all these OMCI messages that would support this given service. It needs to support the protocol on the PON. So basically, I need to send one message at a time. It needs to be acknowledged. It needs to be resent if there's an error. So all these services for getting these OMCI messages need to be available. Right now, as I said, basically ONU adapter is the one that's kind of doing this, but right now it's not very flexible. It's fixed. In the edge core OLT world anyway, in the open source OLT adapter, and so we need to basically take these use cases, take the provisioning, and basically be able to generate different types of sets of OMCI messages based on the service. So this is a very, very high level, use case based type presentation, and we're kind of working on a more detailed presentation that we could maybe present at the lockdown meeting. So this is kind of just a high level approach. So
Sean, this is Kevin. I have a newbie question, if you will. I'm not a GPON expert, more come from the EPON world, so forgive my question. The sequence you have here, you have OMCI setting the TCON on the ONU. I thought that was done at the PLOM channel.
Well, so there is some PLOM messaging initially when the ONU is coming up, right? So basically there has to be the ONU assignment, those kind of things. But that's the initial setup. There's ranging that needs to go on. But this is basically just once we're past that point. Basically, once we're into the I'm going to provision a service on a given ONU. That ONU is already in and ranged and communicating. It has the TC layer, OMCI parameters already set up. So this is basically creating, just creating a service basically on top of that. Is that addressing your question?
I think so. So in your example here, are you using the existing XGEM and TCONs and setting up a service on top of that, or are you creating a new TCON, ALEC ID, and XGEM port for a new service?
Well, my intent was to basically, I guess not pre-provision everything, but once a service is created, it's basically once the open flow messaging for a given service is there, once the XPON configuration is there, then basically it's taking that and creating a new service. This is the initial. So
you're sort of assuming that the TCONs and the XGEMs are already there and setting something on top of it.
Well, I mean, my intent was to create the new ones that we needed. So sometimes you can, in the TR-156 model, for instance, I can create every uni gets 4 gems, and basically it gets 4 TCONs for service plus 1 for the OMCI. But I guess my intent was just to create them as we go. No pre-provisioning unless there is a reason to do that.
Okay. I'll just have to do a little bit more reading and make sure I understand that process, because, like I said, I'm sort of new to the GPON side of things, so still trying to get my feet under me.
No, it's a good question.
I was just going to say, Kevin, this is Philip here. Just quickly, the TCON. So at the PLOM layer, there's I believe there's a PLOM message type for create or assign ALEC ID. And yeah, it's just a very basic setup. And then at the OMCI layer, there's actually a managed entity for a TCON that you have to set up all of the bandwidth profile and all the other things there. So it's not
well. So on the OMCI message down to the ONU, this first one here is where I'm basically the alloc ID is assigned to the ONU, is the assumption, and then basically I'm saying, okay, of the TCONs that this ONU supports, let's say it supports 32, I'm going to assign that alloc ID to TCON number 1, for instance. Or
Yeah, right.
So I mean, this is probably not a completely exhaustive list of the OMCI messages. It's kind of just an example of, once I need to create a service, this is kind of what we have to do. We have to go and make the use of the TCON. We have to set up the gem ports and associate them with the TCON. Then at the OLT side of things, then we have to set up the DBA upstream bandwidth traffic descriptor and the similar assignment of TCONs for that flow.
Yeah, so I think what I was asking is what Philip was starting to answer. There's some flow of messaging that has to be that has to go, I guess, between the OLT and the ONU to actually set up the TCON, right? And that's the piece that I thought should be in this diagram, but didn't
okay, so there's two parts, right? There's a PLOM part for the alloc ID assignment, and then there's a OMCI part, which is setting up the association of the alloc ID with a given TCON.
Right. So the OMCI piece, I get that, right? So and that I understand that piece. It was the flow piece that I didn't see here, and that's why I was confused, I think.
Okay, so basically, yeah. So I guess I would likely have to put in the PLOM messaging as well. So yeah, so I guess that's me.
Yeah, I mean, I would for somebody like me.
Yeah, I mean, I was just kind of focusing on OMCI because that's what that's what we're kind of just talking about. But yeah, so there are PLOM messaging. There's PLOM messaging that needs to go on as well around this. So yeah, okay, good point.
All right, cool, thanks.
But Sean, so of course, so I'm picky here. So it should be working for all ONU adapter and all different kind of the OLT adapter, right? So the model should not limit it to the TNW and the edge core only.
Yeah, this is just an example. Yeah.
Okay.
So yeah, so it could be. I'll take TNW out of the thing. Then just call it ONU adapter. Yeah.
So I have a question as to what the split between the ONU adapter in terms of responsibilities is and the OpenOMCI module is. Would you be able to elaborate on that a bit?
Yeah. So actually, my associate Tim Kempf is working on that. So we will have a presentation at the lockdown meeting. So we need to have some discussion around the architecture of is everything happening within the ONU adapter as it currently is, where so basically the provisioning goes to the ONU adapter and it essentially it generates all the OMCI messaging and does the the retries and the waits for confirmation that the message has been received, and then it moves on to the next message, etc., one at a time. Now, do we want to have this OpenOMCI block that's providing some kind of service that I can just stream OMCI messages to it, or I send the high-level request and that just takes care of it for that particular for every ONU adapt concurrently, and it manages the sequencing the messages one at a time until waits for the acknowledgements, retries, etc. So I think that's something we should probably discuss in the lockdown meeting in more detail, and we will have some presentation material around that. Obviously, if people have
I think what
I'd
Sean,
like to how the current iAdapter interfaces are they going to still be something similar to that? And we also have to look at it in terms of the containerized adapters and how it's going to work and how these common APIs are going to look like across OLTs and ONUs. Because, for example, here you show something called a create multi-cause service. There's nothing like that today. I mean, I guess you just pick something, but there's something else that does similar to what you're saying today. So I just wanted to understand, is it something new that you're trying to propose, or how you're going to extend the existing APIs that we already have? And because that's something that has to be common across OLTs and all ONUs, right?
Yeah, and so what level of granularity is there for creating a service? I mean, you say that there's something currently that asks for a service and gives specifics, or basically does it say, okay, this is my service and this is the TCON gem provisioning? It's an end-to-one service, it's a one-to-one service. It's a service that terminates on a UNI, or it's a service that terminates on a VENet. I mean, there's a lot of details around, what a service is, right?
Right. I think what I'm trying to say, the existing APIs, we need to take a look at them to see how to extend them, or if you're going to change them. We need to look at what. Yeah.
Yeah, no, that's good comment. So is there that's the iAdapter interface definition?
That's correct.
Okay. Yeah, so we should review that. I'll take a look at that. And you think it currently would support what we need, or you think we may need to extend that, or is this Sarisha?
Yes, that was.
Okay.
Yeah, I think a lot of the XPON API can do a fair amount of the lower level information, and just it needs to be extended for COS, other models. So not necessarily iAdapter.
Yeah. Okay.
So that interface has already APIs for the XPON stuff, like for example the gems and alloc IDs and all that. The setup for all that is already in there. So we'd have to see if that's good enough, and we need to extend it for QoS. Like you showed in the very first slide, you showed the relationship between the XPON model and also the QoS model. So the QoS model is still not in play yet in VOLTHA, so we need to extend it for that. There are the XPON models, there is some basics already in there, so we have to see what's available and what needs to be extended from there.
Yeah. So I think the first, like you said, the first step would be to review that interface definition and see if that's going to meet the use cases that we have. And Sean, if there are other use cases around OMCI usage, I mean, this is just a very, I guess, specific set of examples around service creation, right? So, and there's all kinds of PM collection and there's other capabilities that the OMCI gives. I don't know if there are any use cases around those or prioritization of the use cases that we could look at as well, or if that's going to be presented next week in the lockdown.
Trying to.
Okay.
Right now, I know that this, at least for VOLTHA for AT&T, is for the XGS-PON application, right? So, and in our assumption is for the D2 services, the H.248 voice will be a lower priority. So I think about the priority list, I think one of the use case you have is the H.248 pods. I think that's the lower priority than the high speed internet, the data service, and also the multicast. So
yeah, so so good point. So multicast is also another use case here, right? That needs to be able to be provisioned. Okay.
But regarding to the PM stuff, it's once the frame, I think the frame will need to be able to consider to deliver those also. So yeah, I'll work out some use cases and priority. May not be available by next Wednesday, but I think the way I see it is as long as the framework support it. So when do we put that in? So that's a priority, right? So there's I mean the priority of the feature delivery. So
I'm assuming, I haven't really seen any I guess asks for TR-156 4+1 type service model. Anyway, from AT&T or or DT at this point.
Correct. I think our legacy server, our legacy internet and data services, as you said, like what you're showing here, right? So, but there was in the past there was a discussion between the when we tried to find some criteria for the cloud, the one-to-one mapping, that's a TR-156 model was mentioned. So, but our existing XGS-PON still following the legacy. The D1 XGS-PON is following the D1 model. So I think the use case you presented here are probably the immediate need for that.
Yeah. Okay. I guess the other aspect that we kind of touched on was, how do we handle the traffic management in the downstream direction? Is there, there are some ways that we can augment the 385 model, right? To essentially add scheduling points in the downstream. Is that something that's going to be touched on or discussed next week in the lockdown meeting as well?
The way we schedule the traffic management, we put it as a VOLTHA 2.0 delivery, right? Deliverable. So it will, yes, it will be touched, and then if that require OpenOMCI work in conjunction with that, then we need to address that either when that's 3, at least the framework, as I said, the framework to support it, or do you think the OpenOMCI will be part of it? I mean,
well, initially I don't really see the OMCI being affected by the downstream provisioning traffic management. It's more the OLT side of things, I would imagine. Creating schedulers and queues on the OLT in the downstream direction. The only potential impacts on OMCI would be if we need to enable the traffic management on the OLT, right? So if we need to make this very small, but if we needed to just 1 second. So if we needed to provision this upstream traffic schedule at all, like for instance the TR-156 model, which is a little prior right now, but if there's more than one uni, and so there's more than one gem sharing the same TCON, and the TCON's going to have the aggregate bandwidth of both services from both gems, and so we need to limit how much bandwidth each gem can get from the aggregate TCON bandwidth, right? So in that case, you probably need to have some traffic scheduler provisioning for a given gem from a given uni on the ONU. But if we don't support that model, then it's probably not an issue. But okay, I mean, so maybe we could discuss that next week anyway.
Yeah, and we are about out of time for the first presentation, so
Okay.
probably a last call for questions, and other items we likely need to table to next week, or else email also works over the VOLTHA Discuss Exploder. So any last questions for Sean before we switch over to Chip's presentation? All right, Chip, I see you on the list. Are you ready for me to give you presenting rights?
Yes, I should be.
Great.
Okay. And
All right, I can see your presentation. Thank you.
Okay. Yeah, what I wanted, started looking at what it would take, for an OpenOMCI stack, and of course that's pretty difficult to collect people up here at AdTran during the holidays. So I decided it might be best to concentrate on what probably could be one fundamental piece that could be looked at and added and made use of right away to help make OMCI a little bit easier on the ONU and a little bit more resilient. And towards the end, I'll also present basically where I think it might fit into an overall framework. So that'd be like a OpenOMCI stack from a very high 10,000 foot level. And we can refine that as needed, especially based on what comes out of any use cases. So currently in the OMCI stack, it's pretty much as we discussed, it's just a library of functions that help to do frame generation and frame parsing. And from what I can tell, most of the work originally started in the PMC ONU, was improved upon in the Broadcom ONU, and then everybody, of course, copied from that. So pretty much every one of the open sourced ONU device adapters has the same kind of architecture, where they pretty much implement their own transmit and receive capabilities through a received message queue, and the encoding of ME frames is actually done on a per message type. So there's a method to do create an ONTG or a get ONTG request, and to add additional MEs to that, and also different types, creates and deletes, ends up making the functions really explode that we have. And so I looked at a way to come up with a base ME frame type that you can use, and then from it you can request that it generate either a get frame, set frame, create as needed. So, and I finished a couple days ago, I finished some of the as-built information, which is some of the more background of what's out there, if that helps people who aren't familiar with the current OMCI capabilities. So the issues as I pretty much see it is there's a large amount of duplicated code, so everyone's out of sync. Most people's methods to do a receive, it's pretty much hangs a get off that one message queue where receives come in over the proxy channel. And so with that, if the OLT misses the message or a message isn't returned, you pretty much can guarantee that your ONU is going to hang in their message generation, their sort of script is going to hang forever. There's also no matching of transmit and receive transmit IDs. And so that gives you an issue when you start getting autonomous messages coming in from the ONU, such as alarms and ABCs. And as we go to containerized, just doing a transmit and then immediate wait for the next message, it sort of makes it impossible to have multiple asynchronous threads of communication running at the same time. So are there any questions on just some of these basic issues, or? Hello?
Well, I think that kind of argues for some service, right, that you can hand off the messaging to, that they can, then it'll deal with the protocol of retransmission, matching up responses, etc. That now you can asynchronously do other stuff, right?
Yeah. Okay. And what I might want to do is let me just those a couple of slides. So one of the proposals I had was well, it's sort of in two parts. One's sort of a common OMCI communication channel class that allows the user, which initially would be an ONU device adapter, later on it would be something from the OpenOMCI stack, part of the ONU state machine, or perhaps alarm synchronization could handle, would be the transmitter there. It matches received transmit IDs up to transmitted IDs, and when you do a send, it hands you back a deferred specific to that transmit. So at that point, you don't really wait on a queue. You have the defer that comes back that's that's linked to the transmit, and either it'll timeout and off of and return a timeout assertion, or it returns a received message. And so other consumers can add in additional callbacks as needed. Also, when I see one of the requirements is having 2 separate queues for the ONU autonomous messages, because you probably want eventually in the OMCI stack a process that monitors alarm notifications and another one that monitors attribute value change notifications, and then of course statistics and unit test coverage.
So this implies a single implementation language version, which means all ONU adapters would be written in that language to take advantage of this common class.
Yes, if they want to.
Okay.
And eventually I would see it being pushed down where an ONU actually probably wouldn't initially directly interfaces into it if they want to, because when you get the OMCI stack and want proper mid synchronization, you don't really want an ONU reaching around and doing creates and deletes without the stack knowing.
What are the latency issues around this class, and could it be implemented as a separate service with a? Go ahead.
Yeah, I see it probably implemented. I'd see it as a class that if ONU wants to make use of, they would just create an instance of it, and then of course, where we can maybe find ways that if someone needs to derive from it. But I think it could be. This is what we're actually using in our ONU device adapter, and it's actually a fairly small amount of logic. And we could do a code review or whatever if we wanted to look at that.
Yep, understood. I was just wondering if it made sense to be able to separate this into a separate service/container so that it could be used from other languages, or if that would just introduce too much latency.
I think that would probably introduce too much latency and complexity given the size of it. And as of course, that really depends as where if we come up with OpenOMCI stack. Is that a separate container, or does that run within the ONU containers? That's a design decision, that we need to make in a few weeks or a few months.
Okay, thank you.
Okay. So this is, and when I showed the overall picture, it might make a little bit more sense where this might fit in. And the other part is to get away from having to create a different method for every type of message type. Like a create or delete for every ME. I've actually got a base ME frame type, and it allows you to define the ME frame and pass in attributes. Either attributes would either key values pairs if you're doing sets, or just attribute names in case you're doing gets. And then once you create that, you can basically ask it to do, give me the get frame for this one ME, or give me the create frame for this ME. And what I found is that the main code for this ME frame type is probably a couple hundred lines, which mostly it's error checking, making sure that things are valid. And then when you actually derive an ME from it, for many MEs, you can do it pretty much in 1 or 2 lines of code. So that might help get a little bit more coverage of MEs that we need to use to create the OpenOMCI. So if you look at the current code, this is sort of a code comparison. So currently, I did the 2 different parts. You have most ONUs are doing the left side where they do a send, create, gal Ethernet profile, pass it down, and then they yield to wait for the response. And of course, the method that's called to create the gal is Ethernet profile is follows. So if you wanted to do a delete, you'd need to create another different method. So that gets a little bit cumbersome. So the proposal is I basically have a gal Ethernet profile frame, and it pretty much goes through and sets up the data and initializes the class, which is the lower portion, So initially you just create the profile frame with the information that you need, and then from it you, once it's done, the create method on the end actually returns a OMCI message that's basically a create request, and then you just ask the OMCI communication channel to send it. And of course, when it returns the results, that's the results for that one frame. So, and like I mentioned, a lot of this is already checked into our Atran ONU under the OMCI subdirectory, and I've done some cleanup, so I've got a few tweaks to it, but it's fairly easy to understand with what's there right now. So, and this is probably the possible way that it would actually fit into maybe an OpenOMCI framework. So down at the very bottom, the adapter agent has the receive and transmit proxy methods, and then you have the three major classes that's in the OMCI library to start with right now. The MB frame makes use of both the message type entity class and the OMCI frames to generate itself, and then the OMCI communication channel is responsible for doing all the transmit and receives. And in here, the various new ports in the OpenOMCI, you need an alarm synchronizer, you need a MIB synchronizer, you have the ONU state machine, and then you also have a variety of other things to do PM and software downloads. So I wanted to do this, present this as sort of a very high level, maybe for point of discussion for working on a framework for the OpenOMCI stack. And so in that first block, the ONU state machine, pretty much here's the capabilities that I see it needs to provide. And actually there's a lot of common services, for software, like I mentioned, software image downloads and PM uploads needs to be worked on. Okay. And if we actually go back to the original one, before any open OMCI, the ONU state machine or alarm synchronizers or MIB synchronizers is written, the ONU device adapters could probably make use of the OMCI communication channel and also the ME frame capabilities, right now, because that's actually how we're doing ONU OMCI messages now. So it's something that we could, if it looks like worthwhile, form the basis that other people could start using right away. But eventually, like I said, we probably don't want an ONU device adapter to reach around an ONU state machine in the stack and do things on its own. I mean, I guess gets would be okay, but doing any kind of creates or deletes or sets would be an issue.
So it's just this picture, right? So the bottom four boxes, you said is already the existing the Broadcom ONU adapter, basically using those adapter agent, OMCI message entity class, OMCI frames.
Yeah, pretty much. Even ours, we're all using those major classes right now. And that's what's out in the VOLTHA extensions OMCI subdirectory.
Okay.
And there's detailed information on the VOLTHA wiki now on what each file in those do in that subdirectory. And
then the yellow or orange.
Yeah.
Is this something? Okay, I'm just looking at is that so initial the release of the OpenOMCI implementation will be introducing the OMCI communication channel, and then the ME frame blocks. Is that what it is?
That's something that we could make use of right now.
Okay.
And if it's something that's worthwhile to make creating OMCI frames a little easier and also handling receives and transmits a little easier, we could make use of it right now and maybe augment it as needed for other vendors. But hopefully it could form the basis of the lower layers of an OpenOMCI stack.
So, okay, but all these the proposed classes and also the future classes, they are not part of the device adapter, right? So it should be some place in the core, in the VOLTHA core.
Yeah, I see it probably being put over in the extensions/OMCI subdirectory. And at that point, any ONUs can use it as they want. And then, of course, we wouldn't try not to touch any existing OMCI frame or OMCI message or entity class files, so that should a ONU device adapter not want to use the communications channel, they don't have to, or they can move over, whenever they see fit, if it's a benefit to them.
But wouldn't it be the entity classes, or because I think you also did a very good job on the getting you examine the existing MEs, right? So there's only basic set of MEs right now is in that folder or branch. So potentially the content of the MEs will be increased also, right?
Yes, yeah, they could easily be increased.
So
yeah.
But those will still stay within the lower blocks, basically. So okay, right now we're talking about so this is a framework, but the content of each block will be changed because we are introducing this OpenOMCI MEs definitions.
Yes. Yeah, so
okay.
So basically, yeah, basically the entity classes would be added to, and they're just basically a description of each of the MEs. So we'd add additional MEs there, and then we can make use of creating a frame from it by either, if you like, the existing method was to write a new function to actually create the frame, or you just go to the ME frame class and make it and derive a class from it, and it would create the frames for you.
Okay. No, I found that very interesting. It just seems like it's just like the AdTrans proposal and the Redis's proposal sort of, addressing different part of the world. Actually, did you guys talk beforehand, and then it seems like this is a framework it's trying to address, and then the Redis is addressing different aspect of the implementation, right? So that's very interesting.
Yeah, and part of the reason I wanted to stay at the very, very lowest levels is it's fairly common, and the real meat goes into the pink blocks, but that really needs defined use cases first, so we can design those properly and prioritize them first. Because obviously, we don't need time of day services to start with, so that's a block we don't have to add.
Okay. So today, where's the mid? Everybody talking about when the first thing the one you plugged in is the synchronize the MIB. So where's this MIB synchronizer is being done in the VOLTHA 1.2 framework? Is it not being done at all?
Yeah, for the current open source adapters, everyone's just sort of playing a script. So they basically do a MIB reset and then send down a bunch of ME frames. So there is no synchronization or listening to attribute value changes or trying to do any kind of synchronization. It's just pretty much run the script and you're done, and you hope it works. So obviously that needs to be fixed as we start moving some of the OMCI capabilities to actually be driven from XPON information that's over.
Mm-hmm. Okay.
So Chip, I have a question about this MIB synchronizer. What exactly do you have in mind there? Do you want to like do an audit, or what is it that you have in mind for that?
Yeah. Well, we probably need to discuss on it, but I think it probably needs to be able to eventually the vendor ONU device adapter should probably talk through the MIB synchronizer to do all the creates and sets at a high level, but it'd also be responsible for listening to attribute value changes and trying to maintain a consistent view of the ONU, what's in the ONU device adapter with what's going on down in the ONU. But I haven't thought about how to export that information up to a higher level.
Is that completely stateless in your mind, or?
Pardon?
Is that completely stateless in your view, or you're still investigating that?
Oh, I'm still investigating, and what I want to do is get a hold of some of the people who've been dealing with OMCI stacks here at ATRAN for many years, and find out what they wish they could have done differently.
Yeah, I think it can't become completely stateless, right? Because there is a field that the OLT uses to make sure that every time it does an update, the field gets updated, and it has to be the same value as the ONU, right? So there's some state. I think initially you want to basically, upload all the automatically created MEs from the ONU, right? So at least you know what the ME IDs are, etc., right, and what's there.
Yeah.
And that's so I asked the question because I'd like to understand, like, if it's not going to be stateless, like, how are we going to design this? Is it going to have access to, I don't know, some sort of an external database, or something we need to discuss as well?
Yeah. There are definitely some problems, especially as you think that an ONU device adapter can actually, under an HA configuration, could actually migrate to another machine. So that becomes an issue.
Another question I had was, you show the vendor ONU device adapter, which is in white block right now, and I assume that's what is interfacing with the core, and that's where your core-facing APIs are, which today is the adapter interface, but we probably would rename something else when we go to containerized adapters. So there's another set of these APIs, and then you're mapping them to the ME frames that you show, your yellow class, right? So that mapping is also happening in that white block. Is that what it is, or where exactly is that?
Well, pretty much the only thing that the new blocks, like the communication channel, takes over is basically a pass in the adapter agent, a reference to that into the communication channel, because he needs to be able to ask for the device's proxy address, and then also to perform the proxy ARTs and transmits. Or actually the transmit side.
No, I'm talking about the top.
Yeah.
Not the adapter agent, proxy TXRX. Yeah, that's just a proxy, simple proxy message. Proxy interface. I'm talking about, like, for example, if you were to just look at what previously Sean showed, he had like basic cost service or something like that, right? That has to be translated to all his set of MEs, and all that logic is where exactly is that? Is it inside that white block?
I'm not positive on that, because we'd have to figure out what the use cases are and where it's best done. Okay. For the COS. So like I said, this is a very high level view, and I just wanted to maybe start at the bottom of something that we could make use of today and get the discussion going on the framework, once we have some use cases.
Okay. Have you investigated if it would be possible to open up, like, for example, G988, like open interfaces towards possibly whoever wants to use it? Instead of, another set of higher level abstract interfaces, probably maybe something like what G988 already supports. very close to what G988 supports, maybe opening it up as well. Because today, like in your picture, it's kind of buried deep inside, right? It's the ME frame is somewhere in the middle, and it doesn't really have any. The higher layers really don't have any view on that.
Yeah, well, yeah, it was very hard to draw some of these pictures. So, actually, in like the previous example, the ONU device adapter actually has access to the ME frame. If I actually, I tried as much as I could to have the blocks touch where they could, but that's almost, I guess the ONU device adapter has the capability to talk directly to the ME frame class, and as well as the OMCI frame, because it's just Python code. So those
now this
interfaces
is
are there.
To use Python then, right? I mean, you're proposing to reuse some of that existing utility class in the current VOLTHA framework, which is Python based. So basically, all the adapters resort to that.
Yeah, because we're currently using it, within the ONU device adapter itself. So it's, if it needs to have an external interface, we could always add that if needed. So, but I did not want to touch any of the existing classes at all, except to add to them. I didn't want to change any of the interfaces, because that could break everybody's ONU device adapter that's using them.
We are about out of time, so are there any last questions for Chip for today's meeting?
One question is, are we going to share these two presentations on the wiki or somewhere? So I know the time is very short.
Yeah.
And maybe people can take it back as a homework and then prepare for next week.
Yeah, I was going to talk about that as well. Chip, I believe yours is already available. Is that correct?
Yeah, I sent you the PDF yesterday of this.
So,
also, this is on Google Docs.
And it's on Google Docs. So if you don't mind, I'll send out the link to yours in the meeting minutes. And I was going to ask Sean if it's possible. I know you had some questions about template, and so I think Sean Ying and I can see if we can get an answer to you for that. And if possible, would you be able to place yours on Google Docs as well, so that the community could take a look at it before next week?
Sure. That's all.
Okay. So Sean and I will get back to you after the meeting today, and then I'll send out a link to the recording for today. I think at the same time, I'll give a refresher link back to our previous discussion also, if people want to go back and review our preliminary discussion we had that led to this meeting, kind of setting up this meeting. And I think that is it for today, since we're out of time. Last minute questions or comments from the group? All right, and then Kim, if you're still on, I will touch base with you afterwards to check on adapter issues, and then we can handle other things related to the 1.2 release over email. So thank you, everyone, and I will go ahead and stop the recording. Thanks.
Bye-bye.